Problem number 7. Find the z-transform of x of n, which is 2, 3, 0, 2, 5, 0, and then identify the region of convergence. Again here, my x of n is a finite sequence. It is a finite signal with specific number of samples. These are the magnitudes of the sample. So I can say that x of n is a finite sequence. We're going to first find the z-transform of x of n, and then we're going to identify the region of convergence, that where the z-transform converges. What is that specific region where the z-transform converges? We're going to show it later, but first find the z-transform of x of n. Let me represent x of n in 2 dimensions graphically. This is my x of n. Look at here. The graph has been given. So based on this graph, these are the magnitudes of the sample. The very first magnitude is 2. So here, this sample makes the point 2 along y-axis, 1 and 2. Its magnitude is 2 at n equals to -2. Similarly, the second sample has the magnitude 3, 1, 2, 3. It makes the point 3 along y-axis. So along y-axis are the magnitudes of the samples which are here, and along x-axis are the number of n, which is the power of z, that we have z to the -n. Similarly, this 0 here, the sample is 0, the magnitude is 0, so we don't have any sample. Here at 2, the magnitude is 2. This sample makes the point 2 along y-axis, 1, 2. So its magnitude is 2 at n equals to +1. Here the magnitude is 5. This sample makes the point 5 along y-axis, 1, 2, 3, 4, 5. So its magnitude is 5 at n equals to +2. Similarly, for the last one, the magnitude is 0. So here we don't have any sample. The sample is 0 at n equals to +3. But look, sometimes the graph is given where the sequence x of n has been shown in 2 dimensions. We can clearly see that where are the locations of the samples from graphical perspective, where it starts, which are the advanced samples and which are the delayed samples. But sometimes the graph is not given, so you need to identify the origin. What is my origin? If you don't identify the origin, these all values can be the magnitudes for the delayed sample. They can be on the left of the 0, or they can be on the right of the 0. These can be the magnitudes for the samples on the left of the 0 at n equals to negative values, which are the advanced samples. Or these all can be the magnitudes for the samples on the right of the 0, which are the delayed samples at n equals to positive values. So it is pretty important to identify the origin. If you don't identify the origin, you can't exactly identify the sample locations. In graphical perspective, my origin is this. This is my origin. Therefore, I can put the arrowhead on 0, which is the origin of the sequence x of n. Now from here, I can easily identify the locations of the sample, even if the graph is not given. When you put the arrowhead here for the 0, it means that on the right of the 0 we have the positive values. So from here I can see that on the right of the 0 we have the magnitudes for the samples which are the delayed samples at n equals to positive values. On the left of the 0, these are the magnitudes for the samples which are the advanced samples at n equals to negative values. So 2, 3 are at -2, -1. And 2, 5, 0 are at 1, 2, 3. This is my origin. This 0 is my origin. I repeat it. If you don't identify the origin, these all magnitude values, these all values can be the magnitudes for the advanced sequence. You don't know exactly the location of the samples. Or these all values can be the magnitudes for the delayed samples on the right side, if you don't identify the origin. Let me write x of n in the advanced and delayed form. Look here, the magnitude is 2. It is the magnitude for this sample. It makes the point 2 along y-axis 1 and 2. So its magnitude is 2 at n equals to negative 2. At n equals to negative 2. If n equals to negative, then you're going to put positive here. Therefore, I have n plus 2. N plus 2. Because look, n minus into minus 2 will be n plus 2. Minus into minus will be positive. So you put this magnitude 2 as it is and then times u of n plus 2. For the second sample, the magnitude is 3. It makes the point 3 along y-axis 1, 2, and 3. Its magnitude is 3. So put 3 as it is and then times u of n plus 1. It is at negative 1. N equals to negative 1. So I'm going to have n minus into minus 1. Minus into minus is positive, therefore I have n plus 1. I repeat it. If n is negative, then you're going to plug in positive sign. If n is positive, then you're going to plug in negative sign. Similarly, for here, this 0, the magnitude is 0. Put the 0 magnitude here and then times u of n minus 0. At this point, at the origin, the magnitude is 0, which means that I don't have any sample at n equals to 0. So I will put n minus 0. At n equals to 0, I have 0. It is not negative. For the negative, you're going to put plus, plus. For the positive, you're going to put negative. So I'm going to put n minus 0. For this sample, the magnitude is 2. It makes the point 2 along y-axis. 1, 2. So its magnitude is 2. Put the 2 magnitude as it is and then times u of n minus 1. Here n equals to positive 1. So if n equals to positive value, then you're going to plug in n minus 1. You're going to put negative sign. For this sample, the magnitude is 5. 1, 2, 3, 4, 5. It makes the point 5 along y-axis. So put the 5 magnitude as it is and then times u of n minus 2. Why minus 2? Because n equals to positive 2. Therefore, you're going to put n minus 2. Plus for the last point, which is 0. Here, the magnitude is 0, which means that I don't have any sample. So put magnitude as it is and then times u of n minus 3. This point is at n equals to positive 3. Therefore, you're going to put n minus 3. We know that if the magnitude is 0, everything will be 0 for that sample. So 0 times u of n minus 0 will be 0. This term equals to 0. This term equals to 0. I left only with these 4 samples. I have 4 samples here. 1, 2, 3, 4. So you're going to play only with the 2, 3, 2, 5. Look on the left of the 0, I have the advanced sample. This sample is advanced by 2. And the other sample has been advanced by 1. Advanced sample means that the sample starts earlier. It started early. The first sample has been advanced by 2, which means that the sample has been advanced by 2 points. This sample has been advanced by 1. It means that it starts earlier by 1 point. On the right of the 0, these are the delayed samples. This sample has been delayed by 1. Negative 1 means delayed by 1. Similarly, this sample, it is delayed by 2. Negative 2 means that it has been delayed by 2. So it starts delay by 2 points. This sample starts earlier. Therefore, we call it the advanced sample. These 2 samples start later. Therefore, we call it the delayed samples. So the x of n will have only 4 terms. This goes to 0. This is also 0. I left only with the 2, 3, 2, and 5. You can directly find the z transform, which is x of z equals to 2 times z to the 2 plus 3 times z to the 1 plus 2 times z to the negative 1 plus 5 times z to the negative 2. Look, the magnitude of this sample is 2, so put 2 as it is and then times z to the positive 2 because I have positive 2 here. Look, as I said, the power of n is z to the negative n. Z to the negative n. What is my n value? Here for this sample, the n value is negative 2. So when I plug in n equals to negative 2, negative times negative 2 will be positive 2. Therefore, I have z to the positive 2 here. Similarly, for this sample, the magnitude is 3. So put 3 as it is and then times z to the positive 1 because I have positive 1. look, this sample is at n equals to -1. The power of z is z to the -n. When I plug in n equals to -1, negative times -1 will be +1. Therefore, I have z to the +1. For this sample, the magnitude is 2, so put 2 as it is and then times z to the -1 because I have -1 here. Look, as I said, the power of z is -n. What is my n? My n is +1 for this sample. So when I plug in n equals to +1, I will get z to the -1. I have already negative sign in front of the n. For this sample, the magnitude is 5, so put 5 as it is and then times z to the -2 because I have -2 here. Look, the power of z is z to the -n. But what is the n value? The n value is 2. So plug in n equals to 2, you're going to have z to the -2. You can also mention the equation of the z transform. You can plug in the value of x of n in the equation of the z transform, which is x of z equals to summation of x of n times z to the -n. What is my x of n? My x of n equals to this expression. Just plug in x of n equals to this expression here. When you look to the summation, I have n equals to 0 up to n equals to infinity. You can also put n equals to -infinity up to n equals to +infinity. It doesn't matter. Ultimately, we can see that my sequence is a finite sequence. So we pretty much care about x of n. We don't care of this sample, whether you have n equals to 0 up to n equals to infinity or n equals to -infinity up to n equals to +infinity. Now what is the z transform? Its z transform will be 2 times z squared plus 3 times z to the 1 plus 0 times z to the 0 plus 2 times z to the -1 plus 5 times z to the -2 plus 0 times z to the -3. Look, I repeated the same thing. You can do z transform only in one step, or you can mention the equation of the z transform. It is up to you. So z transform of 2 is 2 times z to the 2. Z transform of 3 is 3 times z to the 1. Z transform of 0 is 0 times z to the 0. For the 2, I have 2 times z to the -1. For 5, I have 5 times z to the -2. For 0, I have 0 times z to the -3. So my final z transform is 2 times z squared plus 3 times z to the 1 plus 2 times z to the -1 plus 5 times z to the -2. This is going to be the final z transform answer of x of n. Now what about the region of convergence? When it comes to the region of convergence, let me show you in complex z-plane. This is my complex z-plane. Region of convergence exists everywhere except at 2 points, when z equals to 0 or z equals to infinity. Z modulus must be greater than 0 and must be less than infinity. Look, if I plug in z equals to 0 here, I have no problem. Similarly, z equals to 0, I have no issue. But when it comes to this term, I'm going to write this expression in fractional form because its power is in negative. If the power of the variable is in negative, you can write it in fractional form. Its fractional form will be 1 over z. So by plugging z equals to 0, I will get 1 over 0, which is undefined situation. 1 over 0 is infinity. Similarly, z to the -2 can be 1 over z squared. By plugging z equals to 0, I will get 1 over 0, which is undefined situation again. It is infinity. 1 over 0 is infinity. So I will get infinity here, plus 0, which ultimately equals to infinity. My x of z will be infinity if I plug in z equals to 0. I don't have problem with the first 2 terms when z equals to 0. I have problems with the second 2 terms when z equals to 0. So because of these 2 terms, my complete z transform will be infinity, which is not good for the region of convergence. We know that z transform converges only for the finite sum. For the region of convergence, we need something finite. Our final z transform must be a finite value. Our z transform cannot be infinity. Infinity is not a finite number. Now what happens when we plug in z equals to infinity? If I plug in z equals to infinity here, infinity squared will be infinity, infinity times 2 will be infinity. Similarly, by plugging z equals to infinity, I will get infinity here. So infinity plus infinity will be infinity. I have problem with the first 2 terms when z equals to infinity. I have no problem with the second 2 terms when z equals to infinity, because look, if I write z to the -1 equals to 1 over z and then by plugging is equals to infinity, I will get 1 over infinity. 1 over infinity is approximately equal to 0. When you have infinity in the denominator, it's such a big number that approximately it equals to 0. Similarly, when I write z to the negative 2 equals to 1 over z squared, and then by plugging is equals to infinity, I will get 1 over infinity. 1 over infinity is approximately equals to 0. I will get 0 for this term and 0 for this term. I have no problem. But I have problem for the first two terms. When I plug in is equals to infinity. Infinity plus 0 plus 0 equals to infinity. So my final answer will be infinite. It won't be a finite number. By plugging is equals to infinity. So for the region of convergence, a z transform must be a finite number. Therefore, we can write that z modulus must be greater than 0 and must be less than infinity. Greater than 0. When you look to the complex z-plane, the region of convergence exists everywhere except at 2 points when z equals to 0 and when z equals to infinity. This blank space means that region of convergence does not exist here exactly at z equals to 0 and also at z equals to infinity. So this is going to be the region of convergence of x of n, which is the finite sequence.